Astrobotic just successfully hot-fired a 4,000-pound rotating detonation engine. That puts it squarely in the category of one of the largest rotating detonation engines ever fired. That's not just within small businesses, that's not just in the United States, that's in human history. This is one of the most powerful embodiments of this technology that has ever been created and demonstrated. On each of these tests, we generate over 4,000 pounds of thrust. We achieved steady state combustion in all of our long duration tests, and all of our initial signs are extremely positive. We've got a lot of math to do, we've got a lot of analysis to do, but everything we've seen so far indicates that this engine performed as well as we possibly could have hoped for. One of the things that differentiates what we're doing is a lot of the rotating detonation engine demonstrations that have been done to date have all been at relatively small scale. So in a lot of cases, we're talking a couple 100 pounds of force. Some of them have been incrementally creeping upwards. But to really enable some of these next generation systems, we have to go bigger. And that's exactly what we did. Considering what we did this with, this is a small team working across multiple offices on a very modest budget. We think that not only is this engine efficient, our team is really efficient, and they put in so many hours. So to see this pay off the way it did, and to achieve such a historic milestone on our first try, that was just incredible. This is a model of our Chakram RDRE. This is actually exactly lifelike. This is very representative of what we actually fired. So we fired 2 thrust chambers. It doesn't look like a conventional rocket engine. There's no giant bell on it. It's quite small. You've got an aerospike nozzle coming out the back here. And all of these are designed to propagate these detonation waves. And so what you get to make these RDREs work is you have these supersonic detonation waves that travel in circles around the outer part of this rocket engine. And in fact, we didn't have just one of these supersonic waves. We had 3 detonation waves chasing each other around the outside of this. And that's what allows for this very efficient, very rapid combustion to enable these high thrust applications. There's a number of different opportunities for infusion of Chakram into some of our existing systems. And as we look ahead, that's where this gets really exciting. Is having a rocket engine is one thing. What you do with that rocket engine is really what matters. We're excited about developing this technology, but we're not developing it just for the sake of science projects and advancing the state of the art. We're looking at ways to introduce this into our existing product lines, whether that's our next generation Zogdor vertical takeoff and landing reusable rocket, which will be able to get affordable space access and rapid reuse, so it'll take off and land. But by introducing this into a future Zogdor variant, we think we can get much higher performance and potentially take more payload up higher or faster. It allows us to just do more because we have more efficient combustion. I think most people who are familiar with Astrobotic know about our lunar lander line. And we're certainly interested in looking at ways to introduce this to our lander architecture. There's a number of different opportunities potentially for that, but that's certainly something we're exploring. What do I have next to me? Giddy, this is amazing. Okay.